All right, next up we've got Sam Swift-Glasman from 5AI. Hey Sam, how you doing?
Hi, good, Chris. Thanks for having me.
So give us a little background on yourself.
Cool. Yeah. So before Five, I spent about 10 years in London's West End. I worked on a bunch of different projects for loads of different studios there. And I started using Houdini back in sort of version 9.5, I think, when I started learning, and I've been using it ever since. I've always primarily worked in sort of effects and pipeline tools and dev and sort of R&D. And then I joined 5AI 2 years ago, and I run a team of synthetic training data engineers, and we create synthetic training data for machine learning and training detectors. So yeah.
Very cool. So I know there's a bunch of autonomous vehicle companies using Houdini, and so really interested in its use in that context. Your presentation is about that. Maybe you can give us a little summary of what you're going to be talking about.
Yeah, so I'm hoping it will be quite interesting and novel. I'm not going to go into specifics of any particular features of Houdini, but it's more a general sort of toolkit of how we use Houdini, and we use it for many different purposes. Actually, it's a really handy toolkit for aiding our development, directly creating training data, for analyzing the training data that we create, and I'm going to run through some examples, and also how we deal with data transformations and all that kind of stuff. So hopefully I think it will be quite exciting.
Excellent. Well, let's jump in.
Cool.
Hello, thanks for joining, and thanks to Side Effects for including me in such a great event. It's a shame that we can't be there in person together to go through this talk, but I think it's great that in such times of difficulty, Side Effects and the Houdini community can come together and put together such a great series of talks. I look forward to watching them all, and I feel very honoured to be a part of it. And I'm recording this from my flat in East London. My name is Sam Swift-Glasman. I lead a synthetic training data team at Hive. Before working at Hive, I spent over 10 years working in VFX and animation studios in London. I've been using Houdini since, version 9.5, and in production since version 10. I studied commercial music, specifically sound engineering, at the University of Westminster in London, and also computer science and mathematics at the Open University. My hobbies: I'm a vertical farmer, a musician, a drummer and a guitarist, a father of a very beautiful 4.5-year-old daughter called Amabel, who you can see here with me now, and I'm just a general geek, really. So for my talk today, Houdini for the Mad Scientist, I'm not going to be digging down into any specific Houdini features, but it will be more of an overview of how Houdini can be used to great effect in more of a science and engineering context, in our case to support work in autonomous vehicle development. So to outline the talk, the first thing I'm going to do is just give you an intro to Hive and talk a bit about our work and the company in general. Then I'll dig down into our team and the work that we do creating synthetic training data, and go through some of our work, go through some of the use cases for the data that we produce. And then I'm going to dig down into all of the weird and wonderful ways that we have used Houdini to support our work to great effect. For a bit of background about Hive, we are a UK-based company. We have offices in London, Cambridge, Oxford, Edinburgh, and Bristol. We're building self-driving software and also development platforms to help autonomous vehicle programs. Our focus is building a modular cloud-based platform for system development and assurance, and also delivering advanced online components from our self-driving vehicle stack. We have our own vehicle platform, and last year we ran very successful commuter autonomous vehicle trials in London. Our founders are from a communications semiconductors background, and they've assembled an absolutely world-class team of experts in computer vision, machine learning, robotics, safety assurance, and automotive engineering. It really is a dynamic place to work, and it's a privilege to be working with such a talented team of scientists and collaborating on some of the hardest challenges in science and engineering today. Also on problems that will make a huge impact on mobility all over the world for years to come. Now, specifically, the use cases that we're going to cover today are focused on what our team does at Hive. We are the synthetic training data team, and we are tasked with creating digital synthetic environments that we can then capture in various different ways to provide ground truth, annotations, and metadata. This data can be used for many different purposes, but our primary focus and mission is improving perception performance by providing data that can be used to train detectors. But our data can also be used for development of various systems around the company, but also for testing and verification. So the real case for using synthetic training data is that as we are authoring in a digital world, we are able to provide scenarios that might be difficult to capture in reality. And this is really useful for adding coverage for edge cases within our data. Some examples might be rare vehicles that are very hard to capture on the road, or perhaps environmental conditions that are also difficult to capture. We can even create scenarios that are just impossible to create in reality, because sometimes that can actually be quite handy and useful for training as well, and we'll see an example of that later. Now, because our worlds are procedural, we can offer tunable parameters that can be driven to create different types of content within our dataset. These could include different kinds of sensor simulations. All of our camera models and sensor models have parameters that can be driven. We have different kinds of environmental conditions, and we can also drive the actual contents of the scene and what objects are distributed and where they are distributed as well. So it can be used to great effect to create infinite variety and infinite possibility, but still with a great amount of control. So our team itself is a convergence of fields as well. We have people from many different backgrounds within the realm of computer graphics, all converging on this problem of synthetic training data, both artists and engineers. People like myself from a VFX and animation background. Also got engineers and artists from a games background. All of our work is driven by our director of research. So there's a scientific element to the work that we're doing. And then we've also got engineers from an engineering, visualization, and software engineering background. So it's a real melting pot. And that in itself has been quite an interesting challenge, just to figure out how to combine all of the techniques and jargon from all of our different backgrounds and how we would approach each problem as a team. Sometimes our problems are more based on requirements of accuracy, so we'd be looking more at techniques from VFX, and sometimes it's more performance-based, so we'd be looking more at techniques employed in real-time authoring. So to give you an idea of what we do as a team, I will go through some of our recent datasets that we've authored and talk about some of our results. So the first case being a recent dataset which focused on a technique known as structured domain randomization. Now, this is a very powerful technique for procedurally creating realistic representations of scenes, but also in a way that they can be completely randomized. Every time you roll the dice, you get a completely different scene. So the basis of the technique is that you take a road spline, a very simple road spline, and from that spline, you then extrude out other context splines. So each context spline that comes out from the road, as you go further back from the road, you get different kinds of context splines, and on each of those splines, you can scatter a different class of object, and that will then lead to fairly realistic representations of scenes. Now, in our case, being a UK-based company, we put our spin on it, and all of our assets and content and the general road topologies are all based on the kind of systems that we see in parts of London, a specific target area that we were looking at the time. So our scenes are quite rich in terms of content that would augment real-world data that we had collected at the time. But this could easily be extended with content from any region, really. Every object in the scene is programmatically scattered, so nothing is placed by hand, all based on rule sets. And in our systems, every single context spline and scatter system that we've created has its own randomization. So it's possible for us to control how different parts of the scene get randomized. And every single parameter in our scene is random, including the lighting. We provide ground truth data from the images, not just RGB renders, but we also provide depth information, segmentation masks, and all sorts of metadata about every instance that can be used to further augment the training data. Another technique that our system supports, a dataset that we generated a while back, is a much simpler technique known as unstructured domain randomization. And with this technique, you essentially scatter your objects of interest, in this case, different vehicles and different pedestrian models, are scattered within a scene, and random textures are projected upon them. And there's some little distractor objects that are also scattered within to make this very psychedelic, crazy looking image. It doesn't make much sense to a human being, but is actually very useful for training to pick out shape. Another factor that gets randomized is just different lighting directions get applied every frame. So it's a results business, and as much fun as it is creating these scenes, we are doing it to make a real impact on the performance of our perception systems. And on a recent dataset based on the SDR technique described earlier, we have proved that by taking real world data and augmenting it with some of our synthetic data, we were able to improve both precision and recall on one of our detectors. So now you've seen our work in all its glory, I can dig down a bit into how Houdini has been a really fantastic tool helping us achieve some of the results that we've achieved. There are many use cases on our team, but I'm going to focus on a few key areas that I've identified. These being the first of which is, I think, the most obvious really for Houdini, and that is procedural content creation. So procedural modeling, processing assets. Houdini is such a powerful and rich platform, and the integrations that go off into other DCC apps and render engines is just fantastic. We also, when we're developing and looking at different algorithms, Houdini is quite a nice tool in that context, because it's really very easy to just prototype a very simple system and start playing around with parameters and figure out what exactly you want to put into your model. So it's been very useful in that context as well, to support our development in generating these worlds. We've used Houdini as well for actually processing, directly manipulating data. So when we get mapping data from various sources, we've been able to make networks that we can run to prepare and extract features that are important to us for different systems. And then finally, we're going to go through probably my favorite use case of Houdini at the moment, and that is I use it for a lot of visualization. So as we're adding richer and richer markup into our scenes and more ground truth data, it's really handy to just be able to put together a little graph and just visualize what sort of data we're looking at. And it helps for debugging, it helps to identify problem areas. It's just been incredibly useful in that regard. So to dive right in, the first case we're going to have a look at is content creation. And as I said earlier, this is really the most obvious use case for Houdini. And it's well documented out there how powerful and rich a tool Houdini is for procedural modeling. On some of our other projects, when we were doing more digital twins, when we were relying more on traditional modeling techniques, we would use Houdini still anytime we wanted to do any sort of proceduralism. Procedural architecture, a lot of our sign generation. We created a lot of our assets for traffic signals and poles, and just lots of things that just naturally lend themselves to creating networks in Houdini. And really the power comes when you start authoring within a game engine or within other DCCs, where you can just bring in your digital assets and use them to author rich and complex scenes, especially in applications such as building procedural architecture. It's really handy to be able to create a network that will be seeded and can potentially spin out thousands of variations for the same amount of work that it would take to author one building. Another use case to have a look at now in terms of content creation is world building. So in this example, we're just going to have a look at a procedural roundabout tool that I generated, and this is following the structured domain randomization technique that we were describing earlier. So the idea here is that we could have one roundabout setup that could generate an infinite variety of roundabouts with all sorts of different parameters. This involved really getting into the physics behind what actually determines the topology of a roundabout, and it's quite an interesting topic, more interesting than I thought it would be when I first started looking into it. So the challenge for this tool is to create a physically plausible model, but then still give you the infinite variety and the ability to change the number of lanes coming into the roundabout, and to change the size of the roundabout, and to change the number of approaches. So there's only a range of parameters that actually make sense, but within those parameters we can make infinite variety. And Houdini was such a great platform for prototyping this, because I was able to make very modular components, and then we were able to add more and more complexity as we went along, so we could have more and more context blinds and more attributes that would help us drive more complexity in our scattering systems further down the pipeline. So in this last example, in terms of content creation using Houdini, this is going to go through the idea of just authoring small little networks and tools that can be used by our modeling team to speed up our asset workflows. So we are in the business of generating just tons of assets. We have quite a large asset library, because we need to generate a library that can give us lots of variation, and that's quite important. So for us, really speeding up how we can ingest assets, we have in-house modeling, but we also rely on some outsourcing, and we also buy in models where we can. So what we need really is methods of conforming our assets and getting them to the spec, to the same spec, so that we can apply all sorts of variation to our models, because that is a real key part of the work that we do. Everything that we're building is in the idea of adding variation wherever we can. So that could be the texturing, that could be swapping out wheels in the case of vehicles. I mean, there's just so many examples that wherever we can, we try and make things as flexible as possible. As we are generating synthetic training data for autonomous vehicles is quite a big deal for us and our team. So having a really optimized ingest process where we could do a lot of automated processing and taking a lot of the pain out of these more complex models is actually paramount to us. So one of our tech artists, James Rumbles, put together a Houdini network that actually deals with a lot of the pain points, and it's been a really great tool for us, allowing us to get assets into the pipeline much quicker. So moving on to our next topic in terms of using Houdini in this context, we're going to talk about using Houdini as an aid for development. So quite often, as we've been trying out different algorithms for different kind of world building scenarios and advancing our tooling in world creation, specifically with roads, our sensor simulations, we found many cases where we just wanted to try out a little algorithm before we got going. And so for me, Houdini is perfect for that, and I've really got a lot of use. And actually other members, some of our engineers on the team, have really quite enjoyed it when I've just passed a little HIP file over, so that when they're working on the actual implementation, quite often they just have a little playground to very visually be able to figure out problems. So it's been quite a hit on our team. So the first example to have a look at here is when we started looking at some of the underlying maps for our road tooling that we've been looking at earlier. One problem that we ran into is trying to find a decent method of calculating an Euler spiral, or a clotoid as it's otherwise known, or Cornu spiral, which is a commonly used transition curve that you can use when working out road systems. So, for example, you can use it to work out the transition curve between a tangent line and a circle. Or actually, if you just have two lines, you can work out the transition curve that will transition from one curve into the other with the perfect acceleration. And it was great to start playing around with this because we were trying out different techniques at the time, and so to be able to just smash this out in Houdini really quickly and find out which algorithm worked really well was really, really handy. And we ended up writing a Vex library for a number of functions to do with these transition curves. So the next example of using Houdini to support development is when we started looking at synthetic LiDAR models, and so some more sensor simulations that we're going to add to our data sets. As we were going through our technical design process and going through all the data sheets for all the LiDAR models we wanted to support and talking to our stakeholders on what requirements we needed to support, it was a really handy process just to be able to rough together some little mock-ups and to really work out some of the complexities of twisting and the firing sequences and such, and just to be able to figure out what features were important as we started to develop LiDAR into our system. So Houdini was super handy in that context because it's so quick to just throw together some lines, some points, and write your own visualizers. We were able to just put together and make some pretty tricky decisions very quickly. And again, once we'd played around for a little while and we moved on to the next stage of development, I was able to give a HIP file over to our engineer for reference, which is always quite handy. The next example of using Houdini to support development was a little project that we put together to aid another team in the company who were working on sensor calibration tools. Now we were tasked with putting together a data set where we could essentially vary all the camera parameters, the intrinsics and the extrinsic camera parameters, plus all the lens distortion characteristics of that lens. So this was quite a nice thing to put together into Houdini. We wrote a little lens shader and we were able to just render out some grids and then provide the parameters that had made that view as ground truth. It was a nice little tool and Houdini's perfect for it. The renders were super fast and we could provide as much variation as we needed to. So next example of using Houdini is directly to manipulate data. So, data is king in our world and we really ingest data from so many different sources, and quite often we need to normalize our data into a form that we can use. So for us, in certain contexts, it's been quite handy to bring in different data sources, and Houdini is quite a nice tool for manipulating that data in some contexts because it means that we can visually see what's happening as we're manipulating the data in a very quick way. So in this case, we're looking at a GeoJSON import that we've brought in, which is some Ordnance Survey data. Just need to give Chris Bohr a shout here because he helped work on this tool. Essentially, we're bringing in a lot of Ordnance Survey data here and using some algorithms that we put together to pull out various features of the scene, what types of junctions, and then we could mark up the data for use in our tooling down the pipeline. Now, in this context, we ended up learning a lot about GIS. I never thought I'd learn this much about it. It's an absolutely crazy world, and it's really fascinating once you get your head down there. But for example, a lot of the data we're pulling in is really high precision because it's in such a huge coordinate system, and we'd have to do some transformations which are not trivial to get the data into a form that we could use in a software with the float precision that we had in Houdini. So Python SOPs became our best friend for a lot of this sort of work. But it was a really great way of dealing with this because we could write some importers and do all of our operations of changing coordinate systems in a higher level precision, and then pull the data down directly into Houdini in a normalized form. And then from that point, we could then perform whatever operations we needed to. In this case, we're pulling out features from a road network of where junctions are, for example, and we can add markup and detail to the geometry that we've created, ready to pass further down the pipeline. Last use case I have to show is, I was saying earlier, this has become one of my favorite uses for Houdini, really. As our data becomes richer and more annotated, and we provide more and more different kinds of ground truth with data that we provide, we need to really visualize on our side before we even send data across to other teams. And quite often we're developing, we need to do a bit debugging. If we run into any bugs, we have to debug. And so being able to do that visually is really priceless. One of the big challenges for just in general in our field is that there's so many different backgrounds involved and so many different fields converging in one place that there's so many different conventions in terms of coordinate systems and just small little trivial details that actually add up to be quite complex after a while. So quite often when we were trying to debug transformations, it's really handy to be able to just bring them up onto the screen and be able to actually just work through them visually and see what was happening. So we've written some visualization tools for our ground truth data that we can see here. And it's just so handy to be able to go through, and also as a check when we're making new data sets, we can just run a few runs through our visualizers and just do a quick visual check to make sure we haven't broken anything in our latest builds. And we've started bringing a lot of stuff into our CI pipelines as well, based on this tooling. So yeah, that's all my use cases I have for you today. I hope that was an interesting little look into some novel uses for Houdini in an emerging field. I've always been very evangelical about the program ever since I started learning it many years ago. And I've even used it in my own personal projects. I was putting together a vertical farm a few years ago, and I ended up making a little geeky simulation to figure out where to put my lights. And it was just a lot of... I've got friends who've used it for 3D printing. I mean, it's just such a versatile application. But I think as new fields emerge, I really feel that Houdini has a real place for the geek, and it allows more technically minded artists to be able to hold their own a bit with, even in teams of software engineers. And that for me has been the real power of having learned Houdini, and I think why people are evangelical about the package. And I'll get my little one using Houdini. She'll probably be ready by about version 25, I reckon. So I just wanted to wrap up my talk today just with a few shout-outs, really. It's been a rough couple of months all over the world, I'd imagine, since the lockdown. But there's been just a few little pockets of every now and then I just find a little gem that just really brings a smile. And I just thought I'd share a few of those. Hopefully you guys can get a kick out of these too. The first one, I just want to give a shout out to my buddy Kristen Kane out in Amsterdam, holding it down. He has been making some absolutely killer visuals of Mars using Houdini and Unreal. I mean, it just looks fantastic, so I just wanted to give him a shout out. The next little example I have is this record. This came out right at the beginning of the lockdown. A guy and his little daughter put together this really crazy record. I mean, it's really good, actually. I found it on the Cardiacs fan group. If there's any Cardiacs fans out there, you might enjoy this. So I just thought I tell you guys, you got to have this in your life. And lastly, my whole team, we're real plane spotting geeks, and we're always watching Freedar, which is a UK radar site where you can watch planes go over. and they've had a little UFO here just floating around. I think one of their radar guys is having a laugh, but they change the name every day. So I wanted to give the UFO a shout out from the team, because that's keeping us entertained throughout this whole thing. So that's it. I'd just like to thank Side Effects again for having me, and thank you all for tuning in, and I look forward to the rest of the talks.